So it's the last lecture of the entire course. You've made it this far. Congratulations. And this is also the hardest. Well, it depends how you look at it. I mean, it's hardest in terms of there's a lot of information you have to remember. But you know, it is an open book test. So in a sense, you don't have to memorize as many things. So as long as you have a basic understanding of the key concept, you should be okay. So lecture 12 is the endocrine system, which is a system of glands that secretes hormones, which would then cause changes in bodily functions. And a lot of these pathways, hormonal pathways, involves regulation of some kind of homeostasis. So now the first question says, name 3 pairs of antagonistic hormone and state the type of homeostasis they maintain. We have been learning about hormones since the beginning of Unit 3. First pair of antagonistic hormone that we learned was in the kidney unit, right? And if we are going to fill this in, we can say aldosterone, which is from the adrenal cortex, right? The aldosterone, and the ANH, the anti-natriuretic hormone. They would be working against each other to help maintain blood sodium level, okay, which in turns would affect your blood pressure, right? Okay, so if your blood pressure goes up, ANH will bring it back down. And if your blood pressure is too low, through the RAS, you are going to release aldosterone, which would then bring it back up. Okay. Another pair that we learned 2 weeks ago, I believe, would be the calcitonin and the PTH, right? So calcitonin is released from the thyroid gland when you have too much calcium in the bones, in the blood rather, and the opposite of calcitonin is the parathyroid hormone, which is released from the parathyroid gland, and that's going to be released when your blood calcium level is too low. Okay, so both of them help maintain blood calcium level. Okay. And then there's the third one that you learn from this unit, this lecture rather. Does anybody know what the third pair is? I'll give you a hint. They work against each other to maintain blood glucose level. So anybody know the names of the hormones that does that? No? That's okay. We have insulin, which is released from the pancreas when you have too much blood glucose, and it will help absorb it. And then the opposite of insulin is glucagon. Okay, glucagon. When you don't have enough glucose in your system, glucagon is also released from the pancreas and it will bring it back up. Okay, so that's that. Last week, we sort of talked about the relationship between the hypothalamus and the pituitary gland, but let's do that one more time here because it's quite an important relationship. So over here, we have the hypothalamus. Okay, and down here, kind of dangling from the hypothalamus, we have the pituitary gland. Okay, we have the posterior pituitary gland. And we have the anterior pituitary. How do you know this is the front and this is the back? Well, you can take a look at this structure, right? This here is the optic chiasma, if you remember from the eye unit, right? So that is going to be at the front of the head. So that tells you this is the anterior pituitary. Okay. And what's happening is, I told you last class that you will have a group of neurons that would start, in the hypothalamus, and they would extend their axon into the posterior pituitary gland. So the hypothalamus is physically connected to the posterior pituitary gland, okay, with these neurons. Okay, it's like, the hypothalamus is like it's like a I don't know, DVD player or Bluetooth player, physically connecting to your TV through wires. Okay, so that's what the relationship is, and you are going to be making the hormone from the hypothalamus. You're going to be transporting them down in vesicles through the axon, and they will be stored and released from the posterior pituitary gland. There are two such hormones. There is the antidiuretic hormone, which helps you conserve water, and there is oxytocin, which causes the letdown of the milk as well as the uterine contraction during labor. Okay, so of course, all these are talked about in the lecture recordings. And then there is going to be another set of hormones that will be another set of neurons that will start in the hypothalamus, but then the axon will kind of end, just right here at the bridge that connects the hypothalamus to the anterior pituitary gland, and they will be releasing some regulatory hormones to tell the anterior pituitary gland to release or not release its own hormones. Okay, so we learned these last week, right? There is the releasing hormone that will give the go-ahead to the anterior pituitary gland to release the hormones, or it could be secreting inhibiting hormone that tells the anterior pituitary gland to stop secreting hormones. So we, for our purpose, we only learned about 3 releasing hormones, right? So they could release GnRH, right, that you learned last week. There is another one called CRH, and another one called TRH. Okay, so they all end in RH. Right? RH stands for releasing hormone. Okay, so the gonadotropin releasing hormone, right? The cortical adrenal releasing hormone, and then there is the thyroid releasing hormone. Okay? Again, it's good to know what they stand for because it will give you an idea of what their functions are, but you don't really have to memorize it. Okay, it's just like exactly word for word. You just kind of have to know, ballpark what their name is stands for. Okay. And then from the anterior pituitary gland, we have a bunch of hormones. We have the non-tropic hormone, okay, which includes, let's list the tropic first. Tropic hormones. Okay, so there is the FSH, there's the LH, there is TSH, and then ACTH. So these tropic hormones are hormones that are going to be targeting another gland. Okay, so as you know, FSH and LH, they target the ovaries in female and testicles in males. So that's another endocrine gland. TSH is going to target the thyroid gland, and ACTH is going to target the adrenal gland. Okay, so all these hormones are called tropic hormone because they would affect another endocrine gland. Okay, let me just write that a little bit better. Tropic hormones. And we have the non-tropic hormones. Non-tropic hormones. And that includes growth hormone and prolactin. Growth hormone makes you grow. Prolactin is responsible for the production of milk, okay, when a woman is pregnant. So that's the relationship between the hypothalamus and the pituitary gland. Okay, like physical wire connection, right? Like the DVD player is still one of those, right? Connected to the TV. Over here, it's wireless connection. Okay, it's like your phone casting onto the TV or something. It's not going to have physical neurons going all the way to the anterior pituitary gland. Does anybody have any question before we move on? Okay, well then, let's move on. Next one, complete the following chart related to PTH and calcitonin. So again, we learned about PTH and calcitonin in the bone unit, but you know it's closely related to what we're talking about here. So in the middle, we would have normal blood calcium level. Okay, normal blood calcium level, the homeostatic level of blood calcium. Okay, we know we cannot have too much calcium, right? Because calcium is needed for muscle contraction, for example. So if you have too much, then you might have you know, twitching of the muscle, a little bit of muscle spasm. If you have too little, you might have muscle weakness. That's just one of the many functions of blood calcium. And so what happens is you have increased blood calcium. Okay, maybe you had a calcium-rich meal for a whole week or something. Maybe you took too many calcium supplements. So that's gonna cause your blood calcium to shoot up, and then that will trigger the thyroid gland to release calcitonin. Okay, so thyroid gland releases calcitonin. Okay, so calcitonin is released. Right? When calcium increases, you need calcitonin. That's how I remember which one does what. Okay, there's a IN here, increases in blood calcium. We need calcitonin. And what will calcitonin do? Calcitonin, it's going to help bring the blood calcium level down by acting on the bones. It will increase calcium. It will increase calcium deposition in bones. Right? Let's put more calcium in the bones. We have extra. Strengthen the bones. And we will tell the kidney to take it easy on calcium absorption. So reduce calcium absorption from filtrate. Filtrate is the stuff that is within the nephrons, right? So you wanna reduce the calcium absorption there. On the other hand, if you have a drop in blood calcium, it is going to be detected by the parathyroid gland. So parathyroid gland releases PTH. Now, the thyroid, it's not really showing it here, but the parathyroid gland is on the back of the thyroid gland. So if this is the back of the thyroid gland, you would have 4 little knobs on it. And then the other one is behind the box, I suppose. Those are your parathyroid glands. Okay, it's kind of on the posterior side, the back side of the thyroid gland. The parathyroid gland will then release the PTH, okay, which would have an effect on the bone, the kidney, and the intestine to help bring the calcium level back up. So now that we don't have enough calcium, we're going to take it from the bones. So you will increase calcium absorption from 3 sources: bones, filtrate, and intestine. Okay, so collectively, all these sources should help bring the calcium level back up. All right, so there you have it. That's how calcitonin and PTH work against each other to maintain normal blood calcium level. All right. Next. Complete the following chart related to insulin and glucagon. Yeah, so again, with something similar, we have normal blood glucose. So it's good to draw these flow chart on your own, right? From memory, it will help you remember what they do. So again, we have an increase in blood glucose. So that could happen when you have a meal, right? So for example, after a meal, any meal, it doesn't even have to be like, you know, high in carbs. It could just be like a normal meal, starchy stuff, right? That would bring down your blood glucose. It doesn't have to be like sweet necessarily. So what's going to happen is in your pancreas, we have different types of cells, and the types of cells that release insulin is called the beta cells. Okay, beta islet, right? We just call them beta cells. In the pancreas, will release insulin. Okay. And then we're just gonna put the hormone here, insulin. What will it do? Well, it will basically have an effect on all the cells in the body. So body cells take up glucose. Okay. And it will also act on the liver and promote the conversion, converts glucose into its storage form. So the storage form of glucose is glycogen, right? You learned that last semester. And collectively, these would cause the blood glucose level to decline, which is what you want because you had too much at the beginning, right? So through the action of taking it up from the blood into the body cells, as well as converting the extra into glycogen, we remove the excess glucose from the blood. Next, normal blood glucose. What if you have a drop? Blood glucose. Okay, so example would be like skipping a meal, or if you're fasting. That would bring your blood glucose level down. And this time you would have alpha cells in the pancreas. Will release glucagon. Okay, so that's the hormone glucagon. And again, right, to help you remember it, right? Where is the insulin? Insulin. When there is an increase in glucose, you need insulin. When glucose are gone, right, not enough, you need glucagon to bring it back up. So what does it do? What it does is it will promote the liver to convert. converts all that glucose that you've stored as glycogen into glucose. Okay. And that will bring the blood glucose level back up. All right, so there's your flow chart for glucose regulation. Take a picture if you need to. Ask the questions if you have any. Okay. Next, we have a very big chart, but this chart is just to show you the relationship between these pathways. Okay, they are all part of what we call the hypothalamic pituitary axis. We have three of them, so axes or HPA. Okay, so let's start with the ones that we are familiar with. Okay, in the repeated. Can you repeat the first chart? Oh, okay, like this one. You mean you just want to take a picture, or you want me to repeat as in like explain it? Oh, okay, sure. So when you have normal blood calcium level, it's fine. And then if the calcium level is up, right? So this could be because, again, you had a calcium-rich meal or something. You had some cheese, had some yogurt, drink some milk, and then some ice cream or something, okay? So that causes your blood calcium level to go up, right? If you have too much calcium, then the thyroid gland will release calcitonin. Okay, so the trigger for calcitonin is high calcium level. Okay, let me write that down on this side. Where is my? So calcitonin, right? Let's compare with the chart. So trigger for calcitonin is too much calcium in blood. Whereas the trigger for PTH is too little calcium in blood. Okay. And then where is this from? Well, calcitonin is from the thyroid gland, whereas the parathyroid hormone is from the parathyroid gland, right? Okay. And then we should talk about the effect, for example. Effect. Okay. So calcitonin will, well, since you have too much calcium, you're going to lower blood calcium. Okay. Whereas PTH, because you don't have enough, we are going to increase blood calcium. Okay. So how does calcitonin lowers the blood calcium? It's going to act on the bones and the kidney, right? So because you have too much in your blood right now, where should we put the calcium? Let's put it in the bones, right? So increase calcium deposition in the bones. You're going to take all those extra calcium in the blood and you're going to put them in the bones. And you will also tell the kidney to not take up as much calcium from the filtrate. You're just going to let the body pee it out, basically. Okay, we don't need them. We have too much. Let's just get rid of it from the urine. Does that make sense so far? Okay. And then for PTH, right? You know, you don't have enough. So what is PTH going to do to bring it back up? It's going to, you know, do these three things, right? You're gonna have to get calcium somewhere. you don't have enough in the blood. So let's get it from the bones. That's the easiest, most accessible source, right? In the body, you're going to get it from the bone. Instead of losing all those calcium in our urine, let's tell the kidney to conserve them, to absorb them. Okay, so you can promote reabsorption at the nephrons. And finally, right, if there is calcium in your diet, let's increase the absorption of that as well. Although the cause of low calcium at the beginning might be due to low dietary intake, so this might not always be possible. Okay, so your body might rely on just taking it from the bone, which is why if you have prolonged low calcium level, over time your bone is going to get weaker. Do you have a follow-up question? For the rest of you who are wondering who am I talking to, I'm just receiving like private message from people who have questions, so I'm just answering them. Okay, great. All right, so back to the HPA, right? The hypothalamic pituitary axis, right? So let's start with something that we are familiar with. Okay, let's go back to like last week. Will these notes be posted? Yes, it will be posted. So last week we talked about the relationship between like estrogen and progesterone and all that stuff, right? So just for the sake of reviewing it, let me just quickly write it down here on the side. Okay, you don't have to write it if you don't want to, but let's just take a look. All right, so to keep it simple, we are going to focus on the female, okay, female system. So we have the GnRH, and that's gonna basically increase FSH and LH, right? During the follicular phase, and then that's going to then travel to the ovaries, and in the first half, you're gonna trigger the development of a follicle, and as a result of that, you will increase estrogen. So estrogen will actually go back to the pituitary gland as well as the hypothalamus, and it will have a positive feedback. It will encourage the hypothalamus and the pituitary gland to make even more GnRH and FSH and LH. Okay, so this positive means positive feedback. Okay, the meaning of positive feedback is the original trigger will result in a series of events that would exaggerate the initial trigger. Okay, so another example that's easier to understand is this: giving birth, for example. Okay, like even if you have not given birth before, or you have not seen someone give birth, you can still try to understand this. Okay, so to push the baby out, right, you begin with a little bit of contraction. Okay, that contraction will cause the brain to release the hormone oxytocin. Then oxytocin will go back to the uterus and tells it to contract more. More contraction will result in the release of even more oxytocin, and more oxytocin will then go back and create even more contraction. And this just keeps on exaggerating the contraction, right? Which is what you want when you try to push out a baby, right? Okay, you don't want to shut down the contraction. So this continues to happen until the baby is out. Does that make sense? Okay, so that's positive feedback. Okay. So that's the first half, the follicular phase, and then the second half, right, you will increase again FSH and LH just like before, but now you're gonna have like a lot of LH this time because of the positive feedback, and that will lead to ovulation. Okay, and after ovulation, you're gonna get the corpus luteum that we talked about. And the corpus luteum will pump out progesterone. Okay, so by the time you have progesterone in your system, that means an egg is already in the fallopian tube. There is no reason for you to have another egg at the moment. So unlike the estrogen, which would exaggerate the GnRH and the FSH-LH production, progesterone would do the opposite. It will basically inhibit it, okay? Because we don't need another egg. So this is negative feedback. Okay, so the negative feedback means you're going to shut down the initial trigger, right? So like a thermostat, you set the temperature at like 20 degrees. If the temperature goes down to 18 degrees, it's going to trigger the heat to come on, okay? But once you reach the 20-degree, you will shut off the heat, right? Okay, so that's what the negative feedback is. Does anyone have any question about this diagram? Understanding this will help you understand the rest of the stuff I'm gonna tell you. So if pregnancy does not occur, corpus luteum breaks down, then the progesterone level will drop, right? Once you drop the progesterone level, these negative inhibition will no longer be there, and you begin the cycle again. So if I come to here, the reproductive system, okay, we can say, again, we're just using the female one as a guideline to help us understand it. So if you have, for example, low progesterone, because pregnancy did not take place, right? So the low progesterone will trigger the hypothalamus to secrete GnRH, okay? Because the negative inhibition is no longer there, right? Okay, I'm going to write it down here as a side note. Because the negative feedback is lifted. It's no longer there. You release the brakes. Okay, then the car is going to go. And then what will happen is the GnRH triggers the anterior pituitary gland to secrete FSH and LH. Okay? FSH and LH targets, we talk about the female, so ovaries, to secrete. Okay, so if we talk about the first round, we have estrogen, okay, or progesterone for the second round. So again, just to make a note for you, this is the follicular phase. And this is the luteal phase. Okay. Now, I also want you to know that the, sorry, I'm just looking for the right color here. The estrogen will go back, right? Positive feedback for these things. Whereas the progesterone will go back, but this time they will have negative feedback. Okay. Now, what do estrogen and progesterone do? Well, they will result in the thickening of the endometrium. Okay. How is that? So using that as a template, we can fill out the other ones. So for metabolism, okay, the trigger is low low metabolism. Okay, low metabolism, which is as a result of a drop in T3 and T4. Okay. So when you have low T3, T4, it will trigger the hypothalamus to secrete thyroid releasing hormone. Okay, because the negative feedback is lifted once again. Okay, I'll explain that further in a second. Right, so you remember TRH is an other releasing hormone from the hypothalamus, right? That will then tell the pituitary gland to release thyroid stimulating hormone. Once again, right, all these things, the detail is in the PowerPoints, what they stand for and the explanation, so you can go there. This is just summary, right? And then the TSH, the thyroid stimulating hormone, targets the thyroid gland. Which would secrete T3 and T4. Secretion of T3, T4 will result in increase in metabolism. Okay, again, which kind of makes sense because if you go back to the beginning, the trigger was low metabolism, and then through all these things, you're gonna have increased metabolism. Okay, but just like the progesterone, T3 and T4 is gonna go back and put a brake on the secretion of TRH and TSH. Our metabolism is already normal. We don't need more T3, T4 to further elevate it. Okay, we're gonna suppress it. Okay, and then since you are slowing the production of T3, T4, eventually the metabolism will drop, and then the negative feedback will be lifted, and the whole process repeats once again. So I hope you see the parallel between what's going on with this HPA and this HPA. And again, ask me a question if it doesn't make sense. All right. Here's another one. Stress. Okay, so we're talking about like long-term stress here, chronic stress. Okay. Actually, you know what? Let's not talk about chronic stressors. Let's talk about stress in a non-traditional sense. Okay, like sometimes we say, "Oh, I'm so stressed," right? As in like, "Oh, I have to go to write these exams. I have to go to work. I have to take care of my kids. So many things going on. I feel stressed, right?" So that's the stress that we are familiar with when we are talking about it. But your body can undergo quote stress when you don't have enough resources around. Okay, so like when you don't have enough resources such as glucose or like electrolytes or like minerals, your body is on a cellular level stressed. Okay, and there are hormones that help bring the resources up when they're low. Okay, so one of the hormone that does that is what we call cortisol. Cortisol. Okay, so when you have low cortisol level, is an indication that maybe you don't have enough resources going on. So just to recap a little bit, this is your adrenal gland, okay, which sits on top of your kidneys. Okay, you have two adrenal glands, one on top of one each kidney, and there is the outside and the inside. Okay, so the outside is what we call the adrenal cortex. Adrenal cortex. This is responsible for secreting hormones related to chronic type of stress. Okay, so there are two types of hormones that we talked about in the lecture, and the categories are mineral mineralocorticoids. Okay, and then the other one is glucocorticoids. And as the name implies, these are steroid hormones that would target, maintain mineral levels in the body. And these are steroid hormones that would maintain glucose level in the body. So there are like a bunch of these mineralocorticoids. The major one is aldosterone. Okay, so aldosterone plays a role in maintaining sodium level. We learned that before, and that's considered as a mineral we want to conserve. Glucocorticoid, the main one, is going to be cortisol. Cortisol. Okay, you might have heard of cortisone, which is like topical steroids that your doctor might prescribe to you if you have like acne or something. Okay, those would help with the inflammation. And so these comes from the adrenal cortex. Whereas the adrenal medulla, the inside, that is where you will have immediate stress, like angry dogs running towards you. Your body is immediately stressed. It needs extra resources right now to either fight the thing or run away from it. That is the epinephrine. Right? And related to epinephrine is another hormone called norepinephrine. Okay? Epinephrine is just another word for adrenaline. It means the same thing. Okay, so long-term stress on the outside and more like immediate threat, stressful environment for the medulla. So we will be using the cortisol to illustrate this. So when you have low cortisol level, it will trigger the hypothalamus to release CRH. You see all these hormones from the hypothalamus, they all end in RH, right? They are releasing hormone, which is supposed to give permission to the anterior pituitary gland to release a certain hormone. So GnRH gives the pituitary gland permission to release FSH and LH. TRH gives permission to the anterior pituitary to release TSH. And CRH gives permission to the anterior pituitary gland to release ACTH. Okay. AC stands for adrenal cortical. Okay, so that means this one is going to target the adrenal cortex. Okay, and just to show you once again, the adrenal cortex is the outside, right? Okay. So what does the adrenal cortex do? It will release the mineralocorticoids and the glucocorticoids. But since we're using cortisol as an example, we'll say secrete cortisol. And to keep it simple, the cortisol will result in increased resource availability in the body. Okay, so it's going to do it in various ways. It's going to maybe break down some proteins, get the amino acid, so you can use that to build things. You can break down some glycogen, so on and so forth. All right. Now, just like the other ones, the cortisol will go back and inhibit these things. Okay. Because you don't want to keep on wasting your resources. Once you have enough, let's keep the resources for later use. Let's not exhaust our savings, right? Now there is one extra thing here. If a person is under chronic stress, like not the type of cellular stress that we're talking about, but like actual chronic stress that we mentioned, having exams, taking care of your family, trying to make ends meet, loss of a loved one, all these external stress. In those situations, the central nervous system will actually override override these negative feedback. Okay, so the central nervous system will essentially not allow the brakes to be there. Okay, so double negative becomes positive, right? And that would cause the cortisol level to increase substantially, because when you are chronically stressed, your body actually demands a lot more resources, right? So, you know, this would be like cortisol level here, cortisol level, and then this would be like time. When you're just like not chronically stressed, then the cortisol level might just up and down fluctuate a little bit, right? Because of its own regulation. But once you have introduced chronic stress, then the central nervous system will shut down these self-regulating mechanisms, and the cortisol level will go up. Okay, and then it will reach some kind of higher level. So this is a chronic elevated cortisol. Okay, as a result of chronic stress. Okay, and that's really not good, because then your body is gonna turn into stressful mode. You're gonna break down a lot of resources in the body. You know, you will lose weight. For example, for some people, it could be the opposite. Excuse me, you'll be breaking down a lot of proteins, which compromise your immune system, and so on and so forth. Okay. So there you go. That's the HPA. Does anyone have any question at all? It's a lot to memorize, right? To remember, I know, but hopefully it makes sense. Okay, you really need to redraw this in your own way to understand it. Okay, sometimes, you know, different people interpret it differently, and once you draw it out yourself, it might help you remember it a little bit better. Okay, moving on. This was done in the video. You can watch that. And we have number 7 right now. Name the hormones produced by the anterior pituitary gland. Okay, so again, this time this is the AP, and I know it because I can see the optic chiasma again, right? Optic chiasma. And you can see the pituitary gland is actually nicely nested in this bone. That's part of the sphenoid bone. Okay, you might remember there's a groove on top of the sphenoid bone that lets your pituitary gland sit right in it. So this is the AP, and this is the PP. Okay? Remember, PP does not make its own hormone. Right? It stores the hormone produced from the hypothalamus, namely the ADH and the oxytocin. Okay, so what's going on with the AP? Well, in the AP, we have the tropic hormone and then the non-tropic hormone. So which one targets the bone and the muscle? Which one causes the bones and the muscle to grow? Anybody want to give it a try? Which hormone causes the bones and muscle to grow? Calcitonin is not from the AP though, right? Calcitonin is from the thyroid gland, right? But good try. Also have someone say calcium. Calcium is not a hormone though, right? I'm asking which hormone will cause the bones and the muscle to grow. Let me just write them down for you again, right? The tropic ones, tropic hormones are FSH, LH, TSH, and ACTH. And then we have the non-tropic ones, which is growth hormone and prolactin. So which one targets the bone and the muscle to help them grow? Let's try that one more time. Which of these ones will cause your bones and muscle to grow? Yes, Sierra, that's correct. The growth hormone, okay, GH. If you are no longer a teenager, then growth hormone is it's not going to do much. Okay, this stuff is most important as you're growing up. Okay, I mean, I don't know how old you guys are. If you're straight from high school, maybe you're still growing, so you might still have some growth hormones. But if you're in your mid to late 20s, then you're not growing anymore, right? Like you're not getting bigger, right, so to speak. What about mammillary glands? Okay, which of these would target the mammillary glands? The breast, right? Anybody? That's right, the PRL, the prolactin. It will cause it to make milk. Okay, of course, that's only going to happen during pregnancy, right? And when you're lactating, when you're feeding your baby. Okay, what about ovaries and testes? Okay, so this is done. This is done. Which of these targets the testicles and the ovaries? That's right, the FSH and LH. Okay, FSH will trigger spermatogenesis in guys and oogenesis in female, right? LH would trigger ovulation in female, and for guys, it would just stimulate the release of testosterone. Okay, thyroid gland. Which of these targets the thyroid gland? We only have two more choices, right? And TSH stands for thyroid stimulating hormone. So it will stimulate the thyroid, right? Very good. And finally, the ACTH will stimulate the adrenal cortex. All right. Again, like I said, you can imagine how hard this would be if it's like an in-person test, right? Where you have no reference sheet and you have to memorize all these, right? But fortunately, you have access to your notes during the test, so it might not be too bad. But still, you have to organize your notes, right? And make these things easily accessible during the test. You don't have time to fumble through your notes and try to find the answer. Right? You have to organize it in a way that makes sense to you, and you can find it quickly. So, for example, if I have a multiple choice question and I say, which hormone stimulates the thyroid gland? Then you have to choose TSH, right? So you have to be able to look that up quite quickly. I could ask you, what hormone is released from thyroid gland? Can anybody tell me? Right? Like this is the upstream event, right? What about the downstream event? So the TSH will tell the thyroid gland to do what? To release what? You guys remember? We just did this like, a moment ago on the previous page. Parathyroid is on the back though, right? So so not quite. That's okay. That's okay. Let's go back here, right? Look, the TSH will target the thyroid gland to release T3 and T4, right? T3 and T4, right? So this is going to be T3, T4, like your text forms, okay? T3, T4. How about this one? Right? Anybody remember this one? You can look back, right? Part of it is knowing where to find the answers. What about adrenal cortex? The ACTH will tell the adrenal cortex to release what? That's right, cortisol, right? Or aldosterone, right? All right. So that's a cortical, glucocorticoids. This is mineral corticoids. Okay, what about here? This should be okay as well. FSH and LH. So things like what? Help me out, please. Anyone else here on the in the class can jump in and help? FSH and LH will tell the testes and the ovaries to release testosterone, right? Estrogen and then progesterone, right? Okay, I don't have enough space, but you can write that down. Like, does this make sense at all? Anybody need clarification? Okay. Hopefully that's okay. Now, over here, there's another arrow here, right? Like this arrow, right? So this is the hypothalamus, right? Hypothalamus. So it will release like a bunch of releasing hormone, like GnRH, right? TRH, CRH. And each one of these will trigger a particular thing. So, GnRH will trigger the release of FSH and LH. Thyroid releasing hormone will trigger the release of thyroid stimulating hormone. Corticotropin releasing hormone will trigger the release of adrenal corticotropin hormone, right? So each of them is a permission for a particular one. Okay. Is that okay? Seriously, anybody want to ask anything? Any comments? Already. Name the hormone that best fits each of the following description. All right, so this is a good thing to create cue cards for, right? If you try to memorize this, right? Like when you go to a nursing program, if you're going to nursing program, for example, you're gonna learn all these again, right? So might as well take the time to memorize them if you could, right? Chances are you're gonna return to in-person learning in September, right? So no more online testing. Just a guess. So basal metabolic hormone, that's going to be T3 and T4. Right? These are the hormones that will help you regulate your metabolism. T3, T4 is from the thyroid gland. Essential for T cell maturation. That one, it's a long time ago that we learned it. Okay, it's thymosin, which is from your thymus. Next one. Most important hormone regulating the amount of calcium circulating in the blood. It is released when blood calcium levels drop. Which one is this? You guys want to help me out? Is it calcitonin or is it PTH? Okay. When blood calcium level drops, do you release calcitonin or PTH? What does your note say? Yes, it is PTH. Very good. Helps to protect the body during long-term stressful situation. Okay, that would be things like cortisol, right? Aldosterone. Okay, remember the drawing with the adrenal gland, right? The outside, the adrenal cortex will release these hormones to protect the body during long-term stressful situation. Short-term stress hormone, which aids in the fight or flight response. So that would be things like epinephrine, right? Or the norepinephrine, okay, which is from the inside. Okay, next one. Necessary if glucose is to be taken up by body cells. Which one is this? Is it insulin or is it glucagon? Right, think about that. If you want to take up the glucose, put them in your cells. Do we need insulin or do we need glucagon? If you're thinking insulin, that would be correct. Glucagon is going to be released when you don't have enough glucose, okay, when you're fasting, okay? So your cells want to take up the glucose when you have too much, okay? And insulin will help you. do that. 4 tropic hormones released from the anterior pituitary gland. Okay, we've been writing it all day long, right? So there is FSH, LH, TSH, and ACTH. They are called tropic hormones because they target an other gland, right? Let me just go back here to show you, right? See, these highlighted ones, they are tropic because they target another gland, right? Testicles, ovaries are an endocrine glands. Thyroid gland is an endocrine gland. Adrenal cortex is an endocrine gland, right? Something is an endocrine gland when you release hormones, right? Mammillary gland is not an endocrine gland. It's an exocrine gland because you're not secreting hormone. The milk comes out from the duct. It's an exocrine gland. So that's why these are not tropic hormones, because they're not targeting an other endocrine gland. Okay? Where am I? Right here. Next, acts antagonistically to insulin. So opposite to insulin, right? And it's produced by the same endocrine organ. That would be glucagon. Okay. They're both produced from the pancreas. Beta cells for the insulin, alpha cells for the glucagon. Hypothalamic hormone, important in regulating water balance, that is ADH, antidiuretic hormone. If you're dehydrated, you need ADH. Anterior pituitary hormone that regulates ovarian cycle, FSH and LH. Directly regulated menstrual uterine cycle would be estrogen and progesterone. Adrenal cortex hormone involved in regulating salt level, that is aldosterone. Last but not least, necessary for milk production. Okay, so to make milk, we need prolactin. Okay, to let the milk come down, we need oxytocin. All right. We're going to take a quick break and we'll finish the rest when we come back. All right. See you in 5. All right, let's keep going. Next, what do we have next? We have this chart. Yeah, this is probably a very important chart that you want to keep next to you during the test. It's a summary of what hormones come from where. Okay, so over here we have the oh, sorry, actually there is a, it says list the hormone produced by each gland and the hormone secreted. We'll just say list the hormones secreted by each gland, because of the relationship of the hypothalamus and the posterior pituitary gland. Not everything is produced and secreted from the same thing, right? Okay, so hypothalamus, hormones secreted from the hypothalamus, the ones that we've learned: GnRH, anything that ends in RH, it's going to be it, right? And then there's the CRH. Okay. Anterior pituitary gland. We have our tropic hormone, the ones that will target an other endocrine gland. And then we have our non-tropic ones. Growth hormone targeting the bones and the muscle. Prolactin, mammillary gland. Posterior pituitary gland. It does not make its own hormone, but it will store 2 hormones that are produced from hypothalamus. They are the ADH for conserving water, oxytocin for contraction and let down of the milk. Right? So these are produced by hypothalamus. Pineal gland, right, which is kind of located at the back of the brain. This one secretes melatonin. What does melatonin do? Can anybody tell me? Anybody take melatonin? What do we use it for? That's right, sleep. There's some melatonin in the mother's milk, supposed to help the baby sleep. Let me tell you, usually does not work. Thyroid gland. Thyroid gland, we have the T3, T4 for metabolism. And there is also the calcitonin. When there's an increase in calcium, you need calcitonin to bring it back down. Thymus, that releases thymosin to help with T cell maturation. Adrenal cortex, remember this guy? The cortex is the outside. It's going to secrete things like aldosterone for sodium balance and cortisol for general glucose resource availability. Okay, adrenal cortex is the outside. Adrenal medulla is the inside. Parathyroid, adrenal medulla, epinephrine. And the cousin, norepinephrine. Parathyroid gland, parathyroid hormone. You need that when you don't have enough calcium in the blood. Pancreas, insulin, when you have too much glucose in the blood. And glucagon, when glucose is gone in your blood, when it's too low, you need glucagon to bring it back up. Testicles, testosterone, and ovaries, progesterone, and estrogen. There you have it. Okay. Now, I'm not going to do the next part. You should do that yourself. It's the backwards. It's asking you, where does ACTH come from? Well, you just look it up here, right? Okay, ACTH comes from anterior pituitary gland. So you write anterior pituitary gland. Okay. Go through this exercise yourself. Okay, moving on. Complete the following chart for TRH, TSH, and T3 and T4. Have I done this in the lecture recording? I don't remember. Anybody who have watched the recording, can you tell me if I have done these chart in the recording? I have, right? Okay, great. So I'm not gonna do that. Okay, so all these charts, you can see them in the recordings. Okay, let's take a look at some of the application questions. Jamie has hypothyroidism. His doctor ruled out iodine deficiency as a cause. The doctor ordered a blood test for T3, T4, and TSH. Explain how the results will be different if the problem arises from hypothalamus or if it arises from the thyroid gland. Okay. So let's talk about this hypo and hyperthyroidism. So let's talk about normal first. Normal. So normally, if our metabolism goes down, what happens next is you will increase TRH from the hypothalamus. TRH will then increase TSH from the thyroid, which then increase T3 and T4, which then increase metabolism, right? And at the same time, because T3, T4 will lower TRH and TSH through negative feedback, so you will lower TRH, it will lower TSH, which would then lower T3, T4, and then the metabolism comes back down. Once it comes back down, then these are going to go up again, and it just keeps on going. Again, think of this as like thermostat, right? Temperature comes down, okay? The furnace is going to go up, okay? So temperature goes back up. Once temperature goes up to the desired temperature, you shut down the furnace, and temperature will eventually drop again. And then you're going to turn up the furnace again, and just keeps on going all day long, okay? So that's the normal situation. Okay? So in hypothyroidism, right? Basically, it's characterized by low T3 and T4. Okay? So let's see what the problem is. Okay? So the question says, the doctor ruled out iodine deficiency. Okay? So iodine deficiency is one of the causes for hypothyroidism, right? T3, T4 is the only thing in the body that requires iodine to make. So if you don't have enough iodine, you cannot make T3, T4, which causes hypothyroidism. Okay, your metabolism is going to be low all the time. So the doctor said that's not the cause. Yeah, so he did a test for T3, T4 and TSH, explaining how the results will be different if the problem arises from hypothalamus, pituitary, or thyroid. Okay, so let's see. Look at this path. If the problem is a hypothalamus, okay, hypothalamic problem, okay, what would you expect? Well, the hypothalamus releases TRH, right? So, if the hypothalamus is not making enough, then you would have low TRH, which will result in low TSH, which then in turn would result in low T3 and T4. Okay, so that's the test result if the problem originates from the hypothalamus. Situation B, what if it's anterior pituitary problem? Okay, so that means your hypothalamus is fine, your metabolism is low, then your hypothalamus is going to release TRH. But then your anterior pituitary gland is not responding. It's not being able to make the TSH. So this is where the chain is broken. So you would expect to have low TSH and low T3, T4, despite you have high TRH. And then finally, problem C. If it's a thyroid problem, right? So hypothyroidism means you have low metabolism, which would trigger the hypothalamus to release TRH, which then trigger the AP to release TSH. So you will have high TRH and TSH. But if it's a thyroid problem, you would expect to have low T3 and T4. So those are the different blood test results that would tell you where the problem originates from. Okay. Okay, question number 2. Pitocin is a synthetic version of hormone oxytocin. A woman in the final week of pregnancy who is given an injection of Pitocin, what is expected? What is the expected outcome? This is quite simple. Okay. In fact, this is done normally at the clinical setting. This will induce labor. Okay. So once you injected the Pitocin, it's going to cause the uterus to start to contract. And eventually, as the uterus contracts through positive feedback, the posterior pituitary gland will release its own oxytocin. And once you have a certain level of oxytocin, then the body will take over in its own production and own positive feedback, and that will cause labor to occur. Okay. So that is that. I have posted the test 3 review. Okay? I encourage you to do that on your own. And I will post the answers to the multiple choice section for the test 3 review as well for you to check. Other than that, that is it for the course basically. And of course, there is going to be the lab quiz that you have to do, the 5% one. I believe it's going to be available starting tomorrow or something, and you're expected to finish it by Monday, and then the final test, and that will be it. Okay. So thank you all of you for coming consistently throughout the semester. I think we started with a good 20 something people, but then it's just down to the 7 of you by now. So thank you for your commitment, and I wish you all the best for your next program. And also, if you have a moment, and if you haven't already done so, please fill in the student survey. You know, we do want to get feedback from students so that we can improve on the course delivery. Okay, so that's it. Feel free to contact me if you have more questions regarding the test. Otherwise, good luck and take care. Bye for now.
Sir, I have
Yeah.
a question. So, under what section will these notes be posted?
Oh, it's let me show you quickly. You haven't been able to see them this whole time?
Well, I've been able to find them like sometimes, but
Okay.
can't really, navigate this too well.
Sure. So like, you know, every time after the tutorial in the announcement, I would say, you know, here is the whatever study guide, right? So you just click on that and it will take you to it. Okay. But basically, you can go to the table of contents. Use here, study guide answers. You see that right here?
Yes.
And then that's all of them, right? So then I'll post a new one right here. Okay.
All right. Thank you.
If you can't find it, just email me. I'll send it to you. Okay.
All right. Thank you.
No problem. Okay. Take care, guys. Bye-bye.